All right, folks. Lesson 9, Solving Rational Equation Word Problems, Part 2. So these deal with work rate problems. The ones we were doing last day were generally distance, velocity, and time. Okay, and so you kind of, if it involves distance, velocity, and time, you're going to be making that chart. If it involves work or rate, you're going to be using one of two formulas here. Okay, and they're basically the same. They're just set up different forms. The whole idea behind these work rate problems is that when two people are working to perform a job together, the thing goes quicker, and that kind of makes sense. If you can envision, you do one job, whatever it is, cleaning a classroom by yourself, and if your friend comes to help you, then it'll go a lot quicker. And depending on how quickly that friend goes, maybe they're an even quicker cleaner than you, then the job's going to get done even faster than just half the time. So let's get into a couple examples here. So when they work together, Stuart and Lucy can deliver flyers to all the homes in their neighborhood in 42 minutes. So basically, so far we're going to do like Lucy plus Stuart working together is 42 minutes. This is just the idea of it. When Lucy works alone, she can deliver the flyers in 13 minutes less than when Stuart can when he works alone. So who's the quicker worker? Well, Lucy is, okay? So maybe Stuart's younger, whatever the reason is. Lucy is a little bit quicker because it doesn't take her as much time if she compares to just Stuart's. So let's set up some variables. So x is going to equal Stuart's time, and x minus 13 is going to be Lucy's time. Okay. So when they work together, they take some 42 minutes. So we're going to have 42 minutes. We're going to be using this formula on the right. So the time it takes, so 42 minutes over Stuart's time plus 42 minutes divided by Lucy's rate, so x minus 13, is going to equal one job. Okay, so Stuart's effort plus Lucy's effort, they both finish one job. So let's solve this. So multiply by x and x minus 13. So everything gets multiplied by x and x minus 13. Okay, let's do some slashing. So the x and the x simplify. So you're going to be left with 42 and x minus 13. And the x minus 13 and the x minus 13 simplify. So you're going to be left with 42x. And on the right side, you're left with x and x minus 13. So let's do some expansion and then collecting like terms. So we've got 42x minus 546 plus 42x is equal to x squared minus 13x. Let's bring everything over to one side and collect our like terms. So 42x plus 42x, that's going to give us our 84. And if we add the 13x and subtract x squared, we're going to get, no, I don't want the negative x squared. Let's bring everything over to the right side. So we end up with x squared minus 97x plus 546 is equal to 0. Now those are some big numbers. I don't really want to attempt to factor that. You could. So if you can't quite factor it, let's use the quadratic equation. So negative b plus or minus b squared minus 4ac divided by 2a. Now there's other methods too. I mean, you could graph that on a graphing calculator and see where the intersects are. but let's just do it quadratic here. So x is equal to 97. It was negative 97, but when we put it into the quadratic equation, the quadratic formula, it turns positive. So 97 plus or minus, what do we got here? Negative 97 squared minus 4 times 1 times 5, 46, divided by 2 times 1. And this is going to simplify to 97 plus or minus root 7225 divided by 2. So you end up with two solutions, 91 and 6. All right, and one of these answers makes sense and one of them really doesn't. Does it make sense that it would take Stuart 6 minutes and Lucy negative 7 minutes? No. So that is not possible. So you're ending up with one solution. So it takes Stuart 91 minutes to deliver the flyers. And Lucy would be 91 minus 13. It sort of makes sense in the grand scheme. You know, if it takes 42 minutes for one person to do it, you know, roughly double that. It should be around 80 minutes for one person to do the whole thing. Okay, so you can kind of check your answers for reasonableness. Let's do another example here. And we are going to use the same formula. So like the time over x plus the time y is equal to one job. Okay, and in this case, the job is sharing a bag of popcorn. Okay, so we got one bag of popcorn to share. Fairy can eat the whole bag of popcorn in 20 minutes. All right, so Fairy eats in 20 minutes, and Andrea takes 25 minutes to eat the whole bag. So even just kind of thinking about those numbers, what should our answer roughly be? And if they're both kind of about the same rate, it should be about, I'm guessing, approximately 10 minutes for them both to eat the same bag. So let's set up our stuff here, okay? So we don't know the total time, okay? So what we're going to do is we're going to just do t over 20, because that's Fairy's rate, plus t over 25, that's Andrea's rate, and they're going to eat one bag of popcorn. So we need to simplify this, so let's multiply by 100. And why am I multiplying by 100? Well, I'm trying to figure out what's going to get rid of both 20 and 25. And so if you think of the multiples of 20, 20, 40, 60, 80, 100, and the multiples of 25, 25, 50, 75, 100. 100's that first number. So let's get rid of all this stuff here. Okay, so multiply by 100, and multiply that by 100, and multiply that by 100. So you end up with 100t over 20 plus 100t over 25 is equal to 100. And if you simplify that, 5t plus 4t equals 100, 9t equals 100, and t is going to equal 11.11111, repeating. So they will eat the bag in about 11 minutes. All right, profit problems. So Rita bought a case of concert t-shirts for $450. She kept 2 t-shirts for herself and sold the rest for $560, making a profit of $10 on each t-shirt. How many t-shirts were in the case? So if we knew the number of t-shirts, it would be very simple, but we do not. So let's start with a chart. We're just going to fill in some information. So the dollar amount And then we've got the number of t-shirts and the price per shirt. Okay, so this is the bought information, and this is going to be the sold information. So she bought them for $4.50, sold them for $5.60. We don't know the numbers that she bought, but we do know that she sold 2 less than she bought, so X minus 2. Now the price per shirt is going to be the price divided by the number. So 450 divided by X, and this one is going to be 560 divided by X minus 2. All right, now the whole premise here is we're going to take the sold price, the sold rate, and subtract the bought rate, and we're going to get the $10 of profit. So I wrote this way too big, so I got to zoom in to try and fit all this stuff in here. That chart was obscene. So we're taking the sold rate, so 560, that's how much money they made, divided by the number of shirts. And we're going to subtract the bought rate, so 450 divided by X. And if you get that, so, let's just kind of put in some numbers, right? So if there was like 100 shirts or whatever, you would do like 450 divided by 100. That means that, it costs her $4.5 per t-shirt. Okay, and then if you did like 560 divided by 98, because she's only selling 98, you'd get some other number, roughly whatever it is, $6. Well, that's not enough of a gap. Okay, so we got to figure out what else is going on here. All right, so our common denominator is going to be X and X minus 2. We got to clear the denominators. So X and X minus 2, X and X minus 2, and X and X minus 2. All right, so X and X minus 2. So we're left with X multiplied by 560. And then the X and the X simplify, so you're left with 450 multiplied by X minus 2. And that's going to equal 10X multiplied by X minus 2. So let's further simplify. 560X minus 450X plus 900 is going to equal 10X squared minus 20X. And if you bring everything over to one side, you are eventually going to have 10X squared minus 130X minus 900 is equal to 0. Now, I'm not even going to bother trying to attempt to factor that. I'm going to go straight to the quadratic equation, the quadratic formula. So x is equal to negative b plus or minus b squared minus 4ac divided by 2a. So x is equal to negative 130. So negative. It's going to be a positive in the end, plus or minus negative 130 squared minus 4 times 10 multiplied by 10 multiplied by 900 divided by 2 and 10. So this will all simplify to 130 plus or minus square root of 52,900 divided by 20, and you end up with two solutions, 18 or negative 5. Well, negative 5 makes no sense, so 18 is your solution. So there were 18 t-shirts in the box. So 3 scenarios, basically. The first one is where you don't know their rate, okay, but you do know their times. The second one is you don't know the overall time, but you know how fast each individual rate is. And then we have these profit problems, okay? And the profit problems, set up your charts. and work to an unknown.